Hello, Algebra 2 students. Today we will be doing 6.3 notes, perform function operations and composition. Let f and g be any two functions. When you perform operations of f and g, the new function h is obtained. So we are going to learn how to add, subtract, multiply, and divide functions. So on the right column, under example, it says, let f of x equals 5x, so that's the first function, and g of x equals x plus 2, that's the second function. On the left, we are going to first add those two functions together. So when we add f and g, we are going to obtain h, and this is what we would do. So h of x is equal to 5x, because that's f of x, plus g of x, which is x plus 2. And when you simplify, you get h of x, and that's not h times x, it's h of x, equals 6x plus 2. And then we want to list the domain. That's going to be a big part of this particular section. So our domain is our input values. What can x be so that the function is still defined? Well, if you look at h of x, that's 6x plus 2. And if you look at f of x and g of x, they're all linear. This is linear. This is linear. And when something's linear, x can be any number. So the domain, x is any real number. And we denote that with that r, the fancy r. There we go. And that's how you would add two functions. To subtract two functions, and it tells you what order you need to subtract. So it's f of x minus g of x. So h of x is equal to f of x. F of x is 5x minus g of x. And since g of x is more than one term, put it in parentheses. When you're adding, it doesn't matter, but when you're subtracting, you do have to distribute that negative sign. So let's distribute the negative, because remember, there's a 1 here. So that's negative 1x minus 2. So h of x equals 4x minus 2. And again, the domain is any all real numbers. So I'm going to put over here. Our next one, multiplying two functions. So this time we want to multiply, and multiplying the order doesn't matter. So h of x is equal to f of x times g of x, and g of x is x plus 2. Remember, I'm getting this information right here. Yep. All right, so multiply, so we're going to distribute. So h of x is equal to 5x squared plus 10x. And x can be any real number. Is it always going to be any real number? No. When you run into problems is when you have fractions and radicals, because remember, you can't have a negative number inside the radical with an even index. So the domain is all real numbers. And here's our first case that we will run into a restriction. So to divide, there we go. So h of x is equal to f of x divided by g of x. Now you can't simplify that any further. You can't like cancel out the x's or anything. So that is your simplified answer. However, now we have to list the restrictions. Remember, you cannot divide by 0. Can never divide by 0. Ever, because this is not allowed. right? So what number will x have to be so that you end up with 0 in the denominator, which is what you don't want? So what you always do is you take your denominator, so you take this and you set it equal to 0. Doesn't matter what the numerator is. Subtract 2 on both sides. X equals -2. So your domain is all real numbers except x equals -2. Because if you put -2 in the bottom, -2 plus 2 is 0, and you can't divide by 0. So that would be your domain for the last one. And we'll do more examples. Perform each operation, find the domain of each new function. So the top example that we did was just an overview. Now we're going to do some additional examples. And this time we're dealing with rational exponents because we have fraction exponents. And I think the best way to do these is do the regular stuff, but at the end, put your answer in radical form. So for A, we want to add f and g together. So f is 4x to the 1/2, and g is -9x to the 1/2. At least the fractions are the same, so you're going to combine the numbers in front. So h of x is equal to -5, but leave the variable and leave the exponent alone. And my suggestion here is to write you can box this up as your answer, but you can also write it a different way. So remember, you can write it as a radical. And the base goes inside, and notice the 2 is the index. So this is your index. So it's going to go outside. And for square root, you don't even need to put the 2 there because we know it's a square root. So that will help you. This actually helps us come up with the domain. And so the domain, x can be any number as long as it's 0 or bigger, because you can take the square root of 0 and positive numbers, but not negative numbers. So the way to write it is x is greater than or equal to 0. Now, could you write that out in words? X can be any positive real number, including 0. You totally can, but why bother to say so much? Next one, we're going to subtract. So h of x equals 4x to the 1/2 minus a -9x to the 1/2. And that becomes 4x to the 1/2 plus 9x to the 1/2. And that is 13x to the 1/2. We are just interested in the numbers in front, as long as the base and exponent are the same. So box up your answer, but write it as a radical. Now, you don't put 13 inside a radical, only the x to the 1/2, anything that has a fraction. So x is your base. And again, you have that 2 here. And so again, your domain is going to be all real numbers. Well, actually, no, the domain's going to be x is greater than or equal to 0 again, because you can only take the square root of 0 and positive numbers. Now, we are going to, in our next example, multiply. So h of x equals 6x times x to the 3/4. So remember, x does have an exponent, and it is to the first power. So we can multiply that 1 over 1 and write it as 4 over 4, so it has the same denominator as the 3/4. And when you have the same base, you add the exponents. But you don't add the 6 and this 1 that's here in front of the x to the 3/4. So 6 times 1 is 6, and then 4/4 plus 3/4 is 7/4. So that is your answer. and then write it as a radical. And hopefully you remember from section 6.1. So the index is 4, and this goes in parentheses because the top number is a number other than 1, and that would be 7 here. And when the index is even, so even index, you have to, x has to be positive, 0 or positive, because x cannot be negative or you'll have imaginary. So domain, and if you're kind of lost on what the domain is, just replace x with a number. If you were to put 0 there, you know you can take the fourth root of 0, that's 0, and you can take the fourth root of any positive number. So x is greater than or equal to 0. And our last one for this particular example set, so we have h of x equals 6x divided by x to the 3/4. So again, remember that's 4 over 4, because 1, you can write it that way. And so we can subtract exponents. So for this particular problem, we want to subtract x fourths minus 3/4, and that would give us 1/4. So h of x equals 6x to the 4/4. It's always the bottom fraction or the bottom exponent subtracted from the top exponent. And writing that as a radical, okay, our index is 4. Put that in the crease. Our base is x. And since 1 is our numerator, you don't need to put any of that stuff in parentheses. So again, our domain, oh, this one is harder. You have to look at the domain. When you're looking at division, you cannot, here, you cannot divide by 0. So you can't have x be 0 in the denominator. You don't look at just your final answer. You look at your other stuff as well. So here the domain is x is greater than 0. You cannot have 0 in the denominator, so it can only be positive numbers. Even though you're looking at this is your answer, but you have to look at your individual parts to begin with, and your individual part had g of x in the denominator. This is kind of hard. All right. Moving on to composition of functions. Now, I really like this, and once you get a hang of it, it's not too bad, but it could be really confusing, so you definitely want to pay attention here. The composition of a function g with a function f is written like this: g of f of x. So notice how I have these big parentheses and then I have the little f of x inside, the smaller. Now, what does this mean? So what this means is this is the input. So whatever x is, you replace it in your function f, and that's your input. Once you put in an input, you get an output. So that output then will become the input of g, and then you'll get an output. So this is what the situation looks like. Well, you know what? I'm not going to draw it. I'm just going to explain it. So here's what you do. So substitute f of x into every x in f, and then you'll get an output. So then the output for f becomes the input for g. And if you're thinking, what in the world, how am I ever going to remember this? Examples, practice. So if you look on the back page of your notes, we are going to do an example. So I will try and make this as hopefully painless as possible. So f of x is 2x minus 7. G of x is x squared plus 4. Okay. Evaluate g of f of 3. So this number right here is the input for f, because it's right next to that letter F. So what you're going to go is you're going to go to the highlighted yellow function, and this is how I would write that. So I'm going to write it just this way. So G of, actually, you know what? I'm not going to do that because it could be confusing. So we are going to do one step at a time. So we are going to first input the number 3 in F. So we are going to go over here and we're going to say f of 3 is equal to, so I'm going to the yellow function. Oops. I say that and then I forget to do something. You're going to replace the x with 3 because the input is 3. That's 6 minus 7, which is negative 1. So f of 3 is negative 1. And so that is going to be, this will be your input for G. And we can do that right over here. So G of negative 1. So it's kind of like you have input, output for F. And then that becomes the input for G. So G of negative 1, so you're going to go to the purple function, and you're going to replace wherever you see an X with a negative 1. So on the right side, negative 1 to the second power plus 4. So that is negative times a negative is a positive. 1 plus 4 is 5. So our final answer is 5. So you would say G of f of 3 is equal to 5. And that's how you do that problem. For the next one, we are going to, so this is our input for G. So we are going to go to the purple function, and we are going to replace the right side with 2y, wherever you see an x. So 2y squared plus 4. 2y times 2y is 4y to the second power. And that is your output for G. Now you're going to use that for your input for F. So for now, so you go to the yellow function, and wherever you see an x on the right side, you're going to replace it with 4y squared plus 4. So we have the 2 in front, and then you're going to replace the x with 4y squared plus 4 minus 7. Distribute 8y squared plus 8 minus 7, and we have 8y squared plus 1. Do a couple more, and we are going to not do D because it might be confusing. So you can cross out D, and we just won't do that. Okay. Perform each operation, find the domain of each. So let's see, we have, here's F, and here is G. So we are going to always start in the inside most parentheses. So we're going to, oops. Oh. There we go. All right, so this is our input. Also, pay attention. This G of X is the exact same thing as that. So you're just going to replace that with 5x minus 2. Okay, now wherever you see an F, or x in F, you're going to replace it with 5x minus 2. So go to the yellow function, put your 4 first, and replace the x with 5x minus 2. Close your parentheses, and then put the negative first power. And no, you cannot distribute and call that 20x because you have the negative exponent. Remember, when you have a negative exponent, you're supposed to switch positions. Right now, this is over 1. And so to switch positions, the 4 still stays up on top. The 5x minus 2 goes on the bottom. And the negative 1 becomes a positive 1, the exponent. So that is your answer. And then the domain, x cannot be, remember, you just can't have 0 in the denominator. So you want to take the denominator contents and set it equal to 0. Add 2 to both sides. And then divide by 5. X equals 2/5. So your domain is all real numbers except x equals 2/5. For B, this is the exact same thing as that. So you're going to replace, you're going to have that G out here, and then you're going to have 4x to the negative first power. So go to G, and wherever you see an x on the right side, you're going to replace it with 4x to the negative first. Then subtract 2. That is 20 x to the negative first minus 2 equals 20 over x, because x to the negative first over 1, you're just going to move it to the denominator and make it positive. Don't do anything else to anything. And this is, hopefully you'll see that x, you can't divide 20 by 0, so x can be any number other than 0. So your domain, x is all real numbers except x equals 0. And we are getting close to getting done. So this one, f of x, if you look at the function, the yellow one, it's just 4x to the negative first. So going to the yellow function, replace any x you see with 4x to the negative first. And then you still have that negative 1 here. So that would be, this 4 stays in the numerator, but everything in the parentheses goes in the denominator. Like, oh, you know what? Actually, I'm not going to do that. Okay. So we are going to do this in baby steps here. So here's the first 4, and I'm going to distribute this exponent to each base. So you have 4 to the negative first, and a negative times a negative is a positive. So the only thing you're going to move is this guy right there. So the 4 stays the same, the x stays the same, and then the 4 to the negative first goes in the denominator, and these cancel, so you're left with x. And but before we, here x cannot, this one's a tough one. So here the domain, x cannot, x is equal to, I can't talk here. It's all real numbers except x equals 0. And here's why. In the original problem, if we had started this, and I should have done that, but I'm going to right now, this is the same thing. And so remember, x cannot be 0 because you can't divide by 0. X to the negative first is the same thing as 1 over x. And so that's why I put the x in the denominator. This is just a linear function. Okay, and our last one, g of x plus 1. So wherever you see a g, you are going to replace it with this input. I'm sorry, in g, wherever you see an x, replace it with x plus 1. So go to the green highlighted function, and you're going to have, so g of x plus 1. So on the right side of g, you have 5, and you're going to replace the x with x plus 1 minus 2. That's 5x plus 5 minus 2 equals 5x plus 3. This is your output for g. Now it's going to be the input for f. So f of 5x plus 3 is, so go to the yellow highlighted function. So you have the 4, replace x with 5x plus 3. Okay. 4 stays, the 5x plus 3 gets moved downstairs, and that is your answer. And we need to set this denominator equal to 0. Subtract 3 on both sides. Divide by 5. So the domain is all real numbers except x equals negative 3/5. And those are your notes for today. Have a great day, Algebra 2 students.